Hello one and all. This is Vinay KR of USN 3BR 16ME 188 of 8th SEM from Department of Mechanical Engineering, Bellary Institute of Technology and Management, Bellary. Now I'm going to present a seminar on the topic called Quality 4.0 under the guidance of Mr. Jaiprakash Sir, Assistant Professor BITM and HOD Dr. Edavalli Basaraj Sir, Professor BITM, Bellary. Here is my topic called Quality 4.0. Now let us go into the presentation. These are my contents of presentation. First is introduction to quality, and then history, Quality 4.0, its objectives, key tools of Quality 4.0, access of Quality 4.0, and finally its conclusion. Before going to the Quality 4.0, first we should understand what is quality. Quality is a degree at which an object or entity satisfied a specific set of attributes or requirements. It totally depends on the customer satisfaction. If the quality of the product is good, then the customer is said to be satisfied, or else there is this thing that industry can loses its customer. Quality can also be defined as a degree at which a set of inherent characteristics fulfills the customer requirements. How this quality emerged? We can see the history of this. An American inventor, mechanical engineer, and a manufacturer, Eli Whitney, in 1765 to 1825, is remembered as the inventor of the cotton gin for developing the concept of mass production with interchangeable parts. He was the first person who introduced the term mass production. And later, in 120 years, introduction of statistical process was seen by Walter Shewhart. He was a person who invented the control charts for statistical investigations of the that was enabling them to know the how products are prepared and how it can be done. And he was a person who invented the quality to product to process quality. Next came Joseph Zoran formulated his quality triology, a universal approach to managing for quality. Next comes the Deming. Together with Zoran, had judged a success in implementing a quality management principles in devastated post-World War II Japan. He was a person who postulated the 14 principles of total quality management, and these people are also called as the gurus of total quality management. In 1960s, a Japanese engineer, Jenichi Taguchi, introduced the industry methods for generating statistically designed experiments aimed at providing products and processed by achieving design-based robust properties. He was a person who invented the robust properties for the design-based robot properties. In 1981, Taguchi came to Bell Laboratories, the research arm of Western Electric, to share his experience in robust design methodologies. His methodologies were more advanced when compared to others. Later, 30 years later, industry started facing the big data phenomena. Sensors and modern data analysis systems now offer new opinions for process and product control. Here there is one advancement that industry started using the sensors and manipulated systems for producing the products. This led to considerations of integrated models combining data from different sources. To handle these advanced techniques, Kenneth and Shamul introduced a framework labeled InfoQ. It enabled them to think how to adjust this one and how to take this as a challenge. Next, organizations started hiring data scientists to leverage the potential in the data. In some way, data scientists started getting involved in organizational infrastructures and data quality. At present, we are standing in fourth industrial revolution with most utilization of quality 4.0. Now, Quality 4.0. Quality 4.0 is a crucial dimension of the products and processes. It is considered a competitive advantage for companies and organizations in the global market. Quality 4.0 is closely aligning quality management with Industry 4.0 to enable enterprise efficiencies, performance, innovation, and business models. However, much of the market is not focusing on Quality 4.0 since many quality teams are still trying to solve yesterday's problems. Inefficiency caused by fragmented systems, manual metrics calculations, quality teams independently performing quality work with minimal cost, cross functional ownership, and ineffective supplier communication, among others. The fourth industrial revolution is an opportunity for the quality movement to become a leading force. Objectives of Quality 4.0. The first objective is to give the current state of the market. Manufacturers should access a quality maturity and, if necessary, improve traditional quality capabilities to fully leverage Quality 4.0. Quality 4.0 enables the manufacturers to have a powerful potential at their level. Second, recognize the reality and powerful potential of Quality 4.0. Companies have already deployed Quality 4.0 analytics, apps, data, and connectivity strategies and are realizing the benefits and achieving the differentiation. Third one, many manufacturers already have a digital transforming strategy, them to evolve with Quality 4.0. Many industries and many small scale industries has advanced digital transformation strategies, but they could not implement our Quality 4.0 urges to them to use the quality methods for improving their products. Fourth one, to align quality objectives around those strategies and develop, communicate, and gain support for supporting initiatives. Next, key tools of Quality 4.0. As we are looking at the slide, there are many things that are there in toolbox of Quality 4.0. First is Quality 1.5. It is the first one. We can say it is a history also how it emerges. Next, Quality 2.0, that is basic one, and Quality 3.0 strive to be better, and Quality 3.5 world class, Quality 4.0 state of the art. We are living in an era that is called Quality 4.0. There are five main topics that quality should be maintained, like leadership, culture, ease of data, standard work, and continuous improvement. These are the five things that an industry should follow to for effective quality maintenance. When coming to Quality 1.5, these are the points where the one on point is increased by changing the era of the quality. For example, in Quality 1.5, when we see the leadership, management not recognize quality as a lead driver of success. They knew that quality is there, but they do not know they don't know the importance of the quality, and they neglected that. When it comes to Quality 2.0, management was aware of that and they started implementing it. Next, when coming to Quality 3.0, quality first started in policy, but management decisions do not always support it. Here also there was like they were not supporting it. Even when it comes to Quality 3.5, quality aspects rigorously discussed by management. They started knowing the importance of the quality and started discussing about it, and they want to implement it. When it comes to Quality 4.0, the state of art, management prize the highest value of the products and possessed quality. They came to know the importance of the quality and they implemented it, and the results were known. And many like culture, ease of data, standard work, continuous improvement were the key tools of this Quality 4.0, that so that every industry should follow these rules and they should maintain the quality. Next topic is access of Quality 4.0. First one is data. Data driven decisions have been at the as the heart of quality improvements for decades. Many recently updated standards re-emphasize the importance of evidence-based decision making. However, industry has a long way to go. For every industry, data is a main thing that they should maintain. There are two pictures that how the industry maintains the data: customer services, supplier performance, engineering, manufacturing, etc. And in second pic, there is a slide. See, traditional data like big data. I have given the difference between those two. That something has increased. That is, there are three things in data. That is velocity, veracity, and transparency. Second one is analytics. Analytics unlock the insights captured within the data. Today, analytics are often a stumbling block of quality. 37% of the market identifies poor metrics as a top roadblock to accomplishing quality objectives. Analytics follows four major steps, that is descriptive, diagnostic, predictive, and perspective. In descriptive, it shows that what happened, first the problem, first the origin of the problem, what's the reason, what happened. Next step is diagnostic. It searches the reason why it happened. And predictive, it predicts the more number of reasons that may have taken for this thing, that is what will happen in future. And prescriptive, what action to be taken for making this thing. uh, and analytics fall into four categories. I have explained this, right? Okay, we'll go for next one. Next is third one, connectivity. We know what is connectivity. Every industry should have a connection between them so that they can emerge themselves with a quality. Broadly stated, connectivity is the connection between the business information technology, that is IT, and operational technology, OT, where business technology includes the enterprise quality management system, EQMS, enterprise resource planning, ERP, and product life cycle management, PLM. And OT is a technology used in laboratory, manufacturing, and service. Industry 4.0 transforms connectivity through a polarification of the inexpensive connected sensors that provide near real time feedback from the connected people. In connectivity, there are three things, that is connected people, connected products, and connected edge devices. In connected people, they can leverage a personal smart devices or intelligent wearable devices that sense workers. Connected worker typically have goals of increased efficiency and safety. Communication is very important when it comes to industries. And next, coming to connected products, these can provide a feedback on their performance across their life cycle. They can communicate use conditions, performance, and failure to perform. And next, third one is connected edge devices. Efficiently connect sensed equipment. This approach helps to avoid overburdening central OT systems by streaming large volume of sensor data. In this way, edge devices often perform analytics at the device, make predictive, prescriptive decisions, and decide which data to send to central OT systems. The fourth one, next coming is fourth one, that is collaboration. Collaboration is a critical for a quality management as quickly is by nature cross-functional and global. Companies execute traditional quality business processes with the help of digital messaging, that is email, Gmail, etc. Automated workflows and portals. Much of the market has set to take advantage automated workflows and portals, and in fact, only 21% have adopted to core EQMS. I said EQMS is a enterprise resource planning. Sorry, enterprise quality management system. Sorry. Okay. Collaboration is a powerful fuel for innovation and quality improvement and has been profoundly transformed by connectivity, data, and analytics. Leaders should consider how they collaborate and build a secure and reproducible data sharing strategy that meets objectives such as better competency, more streamlined oversight, improved security, and audit ability. Next is app development. You know that in smartphones we have more many number of apps that we download and we use. Okay, now in industry there are many number of apps that are designed for the industries for better working of the instruments. It is a wireless network where they can control from one place, and the what the machines that can be controlled by the remotes, etc. App development is something everyone can relate to. Their apps for everything. Apps are the mechanisms through which companies fulfill, process, collect, and expose data, visualize analytics, and establish the collaboration. Technology providers are increasingly providing native mobile apps, downloadable and Android and iOS, to provide a higher quality experience that works on smartphones. Next comes the scalability. Scalability is the ability to support data, volume users, devices, and analytics on a global scale. Without global scale, traditional quality and quality 4.0 are much less effective, unable to harmonize process best practices, competencies, and lessons learned corporate wide. Scalability is critical when industrializing solutions. Assess the current scalability of in-house systems and be sure to consider both global reach and data complexity when deploying either traditional quality or quality 4.0. This is the app development picture. See it how it emerges. See big data analytics, collaboration, mashup apps. Next comes the culture. Many leaders have an initiative to develop a culture of quality, since quality often owns process execution with insufficient participation and ownership from the other functions. A company that has a culture of quality exhibits four key elements: process participation, responsibility, credibility, and empowerment. You can see the two pictures down. It states that 36% of the companies cite a lack of culture quality as top challenge to achieve the quality objectives. Only 13% of cross-sectional teams clearly understand how quality contributes to strategic success. Many don't know the what is a quality and how do we maintain that. It's very important for industry to maintain that. Next, finally, the conclusion. Quality 4.0 isn't it's not a story but technology. It's about how the technology improves culture, collaboration, competency, and the leadership. Quality is a data-driven principle. Quality is responsible for integrating innovation with quality and managing the innovation. It creates a maturity levels towards the fourth industrial revolution. It gives information about modeling and simulation for evidence-based quality engineering. These are my references that are made for the following presentation. First is a Quality 4.0, The Challenging Future of Quality Engineering by Avigator Johansson and Ron S. Kennett. The divine number is present, and it was published on 27 February 2020. And I have made some points by using the googlescholar.com and wikipedia.com. And finally, second paper was Quality Managers and Their Future Technological Expectations related to Industry 4.0, and the author's name are there, and it was published on 1st March 2018. Thank you.